Hello students, so we are doing exercise 21 proof trigonometrical identities, isn't it? In our previous video we have completed question number 1 to 5 of question number 1. So today we'll start from question number 6 onward of question number 1, okay? So let's begin. In the left hand side we have cos a upon 1 plus sin a plus tan a, and we are asked to prove this equals to sec a, isn't it? So let's begin. LHS equals to cos a upon 1 plus sin a plus tan a. This is what we have in the left hand side, and we are asked to use this and prove equals to sec a. So let's copy this cos a as it is, cos a upon 1 plus sin a, cos a upon 1 plus sin a. Now plus tan a means sin a by cos a, isn't it? Tan a means sin a by cos a. So let's take the LCM of the denominators, cos a and 1 plus sin a. The LCM will be cos a into 1 plus sin a. Now cos a into cos a, cos square a, cos a into cos a, cos square a, because 1 plus sin a into cos a gives us this whole thing. So cos a into cos a is cos square a, plus cos a into 1 plus sin a gives this whole thing. So 1 plus sin a into sin a, that is sin a into 1 sin a, plus sin a into sin a is sin square a, sin square a, isn't it? So now we have cos square a plus sin square a. Cos square a plus sin square a means 1, isn't it? I think you know the formula. Sin square a plus cos square a equals to 1, isn't it? So cos square a plus sin square a means 1 plus sin a, plus this sin a comes here, sin a. In the denominator we have cos a into 1 plus sin a. Now this 1 plus sin a from the numerator and 1 plus sin a from the denominator can be cancelled. So we have 1 upon cos a. So 1 upon cos a means cos and sec are the reciprocal of each other, isn't it? So if we bring this cos a to the numerator, it becomes sec a. So this is what we have in the right hand side, equals to RHS. Hence proved. Now let us do question number 7 of 1, okay? This question is similar to the question number 6, okay? So we have sin a upon 1 minus cos a minus cot a in the left hand side, and we are asked to prove this equals to cosec a in the right hand side. So let's copy left hand side first. LHS equals to sin a upon 1 minus cos a minus cot a. So sin a by 1 minus cos a we copy as it is, okay? Sin a by 1 minus cos a minus cot a means cos a by sin a. Cot a means cos a by sin a, isn't it? So let's take the LCM of the denominators, sin a into 1 minus cos a. This gives us sin a into 1 minus cos a, isn't it? So sin a into sin a, sin square a, minus cos a into 1 cos a, minus into minus, plus cos a into cos a, cos square a. So this sin square a plus cos square a is 1, isn't it? Sin square a plus cos square a means 1. 1 minus cos a, this minus cos a comes here, cos a. In the denominator we have sin a into 1 minus cos a. So 1 minus cos a from the denominator and 1 minus cos a from the numerator can be cancelled. So in the numerator we have 1, and in the denominator we have sin a, isn't it? Let me continue here. So 1 minus sin a, 1 by sin a means sin a and cosec a are the reciprocal of each other, okay? Sin a and cosec a are the reciprocal of each other. So 1 upon sin a can be written as cosec a. Are you getting me? 1 upon sin a, if you take the sin a to the numerator, it becomes cosec a. So we have cosec A in the right hand side equals to RHS. Hence proved. Now let us do question number 8. Okay, we are asked to prove this: sin A minus cos A plus 1 upon sin A plus cos A minus 1 equals to cos A upon 1 minus sin A, isn't it? So let's do this. In the left hand side we have sin A minus cos A plus 1 upon sin A plus cos A minus 1. Okay, let's divide the numerator and denominator by cos A. Okay, dividing numerator and denominator by numerator and denominator by cos A. So sin A by cos A minus cos A by cos A plus 1 by cos A, isn't it? Here we have sin A by cos A plus this cos A by cos A minus 1 by cos A. I am just dividing the numerator and the denominator by cos A. Okay, we can do this. So sin A by cos A is tan A minus this cos A and cos A can be cancelled. We have 1 here plus 1 by cos A is sec A, because cos and sec are the reciprocal of each other. So 1 by cos A means sec A whole upon sin A by cos A means tan A plus cos A and cos A can be cancelled. So 1 minus 1 by cos A is sec A. Okay, now let me continue here. Tan A minus 1. So let me write this plus sec A before and minus 1 later. Okay, tan A plus sec A, tan A plus sec A, tan A plus sec A, and then we have minus 1. Okay, so you know that sec square A minus tan square A equals to 1, isn't it? So instead of 1 I can write sec square A minus tan square A, isn't it? So now this minus comes here. Okay, this minus comes here, and instead of 1 I write sec square A minus tan square A whole upon, in the denominator we have tan A plus 1 minus sec A, tan A plus 1 minus sec A, isn't it? So tan A plus sec A I copy as it is, tan A plus sec A, this minus comes here. Okay, sec square A minus tan square A, this is A. Let us assume this sec A as A and tan A as B. So A square minus B square can be written as A plus B into A minus B, isn't it? A plus B into A minus B, sec A plus tan A into sec A minus tan A, and in the denominator we have tan A plus 1, tan A plus 1 minus sec A. So now let us take tan A plus sec A common, because we have tan A plus sec A here. Sec A plus tan A and tan A plus sec A same thing, isn't it? So tan A plus sec A and tan A plus sec A common. Tan A plus sec A is taken common outside. So within the bracket remains, so this tan A plus sec A is taken common. So 1 minus, isn't it? This is taken out. So 1 remains within the bracket, minus into plus sec A, this sec A plus tan is taken out, so minus into plus sec A is minus sec A, and minus into minus tan is plus tan A. isn't it? So in the denominator we have tan A plus 1 minus sec A. Now you can see this tan A is plus, this tan A is plus, this one is plus and this one is plus, this sec A is minus and this sec A is minus. So same number, you can cancel this two. We have tan A plus sec A left now, isn't it? So you can write this as sin A by cos A. Tan A can be written as sin A by cos A. Cos A plus sec A is 1 by cos A, isn't it? So let's take the LCM. LCM becomes cos A. So cos A into 1 gives us cos A, that 1 into sin A is sin A, plus cos A into 1 gives us cos A, that 1 into 1 is 1. So now we need 1 minus sin A in the denominator, isn't it? 1 minus sin A in the denominator. Now let's multiply this by 1 minus sin A in the numerator and in the denominator 1 minus sin A, okay? We can do this because this and this can be cancelled. So now A minus B, 1 is considered as A and sin A is B, okay? A plus B, A minus B. Can you see? A, 1 is A and sin A is B. A minus B, A plus B means A square minus B square. Okay, A square minus B square. So 1 square is 1, so no need to write 1 square. In the denominator we have cos A into 1 minus sin A, isn't it? So 1 minus sin square A can be written as 1 minus sin square A is cos square A, isn't it? Cos square A whole upon cos A into 1 minus sin A. So this cos A and this cos A from the numerator can be cancelled. Here in the numerator we have cos square A. So now remains cos A in the numerator, cos A upon in the denominator we have 1 minus sin A, 1 minus sin A. So this is what we have in the right hand side, cos A upon 1 minus sin A equals to RHS. Hence proved. I hope you got this. So in the left hand side we have root under 1 plus sin A upon 1 minus sin A, and we are asked to prove this equals to cos A upon 1 minus sin A, isn't it? So let's do this. LHS equals to root under 1 plus sin A upon 1 minus sin A. Okay. Now since we need 1 minus sin A in the denominator, so let's multiply the numerator and denominator by 1 minus sin A. 1 plus sin A into 1 minus sin A. Okay. 1 minus sin A into 1 minus sin A. I'm just multiplying the numerator and the denominator by 1 minus sin A. So this gives us A plus B into A minus B. 1 is A and sin A is B, okay? A plus B into A minus B is A square minus B square. So 1 square is 1 and sin square A. So A minus B into A minus B is A minus B whole square, sin A whole square, isn't it? So root under 1 minus sin square A is cos square A, isn't it? 1 minus sin square A means cos square A, and in the denominator we have 1 minus sin A whole square root. So this square and root can be cancelled, so 1 minus sin A remains in the denominator. Root and this square gets cancelled, okay? Now let us continue here. So root under cos square A means this square and root can be cancelled, so cos A remains in the numerator, and in the denominator we have 1 minus sin A, 1 minus sin A. Okay, so this is RHS and it's proved. Now let us do question number 10. Let us do question number 10. This question is similar to question number 9, isn't it? So we need 1 plus cos A in the denominator, so let's multiply the numerator and the denominator by 1 plus cos A. Okay, so LHS, first let us copy LHS. LHS equals to root under 1 minus cos A into upon 1 plus cos A. This is what we have in the left hand side, isn't it? So let's multiply the numerator and the denominator by 1 plus cos A. Okay, so 1 minus cos A into 1 plus cos A whole upon 1 plus cos A into 1 plus cos A. This 1 plus cos A and 1 plus cos A can be cancelled. Okay, so in the numerator we have 1 minus cos A into 1 plus cos A. This means A minus B into A plus B, isn't it? So A square minus B square. A square is 1 square, 1 square is 1, 1 square minus cos square A upon 1 plus cos A into 1 plus cos A is 1 plus cos A whole square, isn't it? So let me continue here, equals to, so 1 minus cos square A means sin square A, sin square A whole upon 1 plus cos A whole square, 1 plus cos A whole square, isn't it? Now let us remove the square from the numerator, square root from the numerator with this square. So sin A, what do I mean to say is this square and square root can be cancelled. Okay, now remains sin A. Similar goes to the denominator, this square and square root can be cancelled, so 1 plus cos A. So this is what we have in the right hand side, isn't it? Hence proved. RHS. I hope you got this. Thank you so much. I'll continue the remaining question in the next video. Okay.